Okay. Hi guys, my name is Ayodeji Saliu. I am a senior software engineer at Andela UK. I work with Guaranty Trust Bank, but I was working with them through Andela, and I'm here today to present a very important topic because I figured that a lot of engineers, new software engineers, senior software engineers, you know, always want to build highly scalable applications that can scale, thousands, that can scale millions of users, and we comfortably, handle traffics and all that without any unnecessary pain or any unnecessary hassle, during development. So I'm here today, to break down these processes. I'm here today to explain these concepts based on my personal experience because I've been a software engineer for over 5 years now. Senior software engineer for over 5 years. I've been doing engineering for more than 7 years. Yeah. So I'm here to explain the concept of building highly scalable applications. I'll be using Angular for front end as the stack, and I'll be using .NET Core for the back end. And of course, I'm going to be talking about a lot of DevOps related stuff because I'm also a DevOps expert, an Azure DevOps expert. So I'm also very familiar with the environment side of things. Let's proceed. So today I'm going to be talking based on these agendas, this topic, this list specified here. Number one is the problem statement. I'm going to be stating the problem statement, which is exactly one of the concerns that developers have. Having to build a scalable system, having to build systems that are as big as Netflix, that are as big as Spotify, that can manage traffic. Because sometimes you wonder how millions of users can use a platform all at the same time, and there's nothing breaking, there is nothing slugging, there's no sluggishness and all that. I'm going to be setting that in problem statement. Then I'm also going to be specifying the high level architecture of the setup. That is, I'm going to be showing you guys how it's being set up from the front end, and also how it's been set up from the back end, and also how the environments are being set up. Then I'm also going to break it down into the front end side, the back end side. I'm aware that some people are mostly on the front end side of things, the front end experts, and some people are also back end experts. So I'm going to be talking about the front end patterns and the back end patterns, and of course I'm going to be talking about a lot of things around caching, because of course caching is very important when you're when you're trying to save data to millions of users. You have to do this in split seconds. So of course I'll be explaining the caching technologies. I'm going to be explaining how data is being passed around and all that. Of course, I'm going to be talking around observability, so that's something around what's it called, ELK and all those bits. Then security is also very important. I'm going to be talking around security and DevOps. So let's proceed. So first of all, the question is how to architect a product. How can I architect a product that will serve millions of users? So the objective is that you want to build a system that will maintain over 99.95 availability for core flows. That is, the core things happening on the app should always be running for 99.95% of time. That is, it should always be running. Then another point is that you want fast deployment. The truth is that when you are building, when you have a system like Netflix, of course you need to have multiple teams working independently. Imagine a situation whereby you have a team managing let's say, the feeds part of Netflix. You have another team managing let's say the ads part of Netflix. There are different teams working independently, and they are still churning out products every single week. So how do we achieve that? That's also one very important thing that we're going to be talking about today. Then apart from that is cost. Cost is always very important. On Netflix today, over 1 million users have coming on the system. How do you manage cost? Because it's actually costly to run a system like Netflix. So how do you manage cost such that when you try to make calls to this system, it doesn't take forever. It doesn't take it doesn't have to cost this, it doesn't have to cost developers so much. It doesn't have to cost the owners of the system so much, for running this application, this architecture. So let's proceed on that. One thing I want to talk about is also the scope of the project. I'm going to be using Angular for the front end, and of course, Angular Angular as a front-end framework already has everything you need. I mean, Angular as a front-end framework is is a framework that helps to handle all of the things you need easily. I mean, ranging from the front end, HTML part, everything is simple and well elaborated on in Angular. Then CDN, called Content Delivery Network. So since Angular is going to be responsible for building the HTML pages, JavaScript pages, and all that, CDN is how you deliver these static websites across the network. So in the sense that, imagine I am in Nigeria and somebody is in the UK wants to access my website, right? Imagine them having to go through the route of accessing the website directly from the UK. It's going to, of course, opening the website the first time is going to take long time before they can access the website. Hence, we need a CDN. A CDN is like a system that caches your website across different geopolitical zones. Let me just say it like that. So, for example, if there is a CDN like Cloudflare in South Africa, which is closer to Nigeria, it's better. It's the CDN places this website they are in the UK on South Africa server, so that way is faster for you to load up the UI. Apart from that, what is API gateway? And why is API gateway in the middle? API gateway, from the word gateway, API gateway is like the middleman between the front end and the back end services. Don't forget, when you want to build an application or a system for millions of users, of course, you have to employ the microservices architecture, in the sense that you'll be having multiple teams working on different modules per time, working independently. So, for example, in Netflix can have over 1,000 teams, over 1,000 people, over 1,000 teams that contains, let's say, 5 people. That's like 5,000 people. That's 1,000 times 5. So imagine that kind of a system that has like 1,000 microservices, right? Imagine now you don't want to make a request from the front end to one of those services. Imagine having to call those APIs. Imagine 5,000, 1,000 teams managing, over 5,000 APIs. I'm sure that's going to be a hell of a mess having to, access those URLs, simultaneously on the front end. That's the point of API gateway. So API gateway is that guy that routes the network, that routes the calls from the front end all the way to the back end. So when you specify the URL, the API gateway is that guy that will manage all the calls. API gateway is that central guy that if you want to probably do some things like validations, you want to do some things like some security checks before you access any microservices, that's that guy. So for example, let's say you have payment services, let's say you have dashboard services, right? When you call, instead of you having to put some validations on each of these services, right? API gateway is that central guy that can have done everything for you before you go ahead to access those services. So if you're thinking microservices, if you're thinking building system for for over 1 million people, API gateway is a must have, because if you don't have that, there'll be issues for you, passing, routing calls or API calls from the front end all the way to those services. Now, what are microservices cluster? Microservices are very simple. See them this way. Microservices is like having your services in small chunks. So in the sense that, for example, you can have payment services, that's a microservice. You can have, let's say, dashboard services, that's a microservice, right? And they are all working independently. So now those microservices can as well communicate with one another using technologies like gRPC and all those. Of course, gRPC is not like REST. gRPC is way ahead of REST because it has some other dynamics to it. For example, it uses HTTP2, unlike REST that uses HTTP1. So gRPC is the technology that microservices use to communicate within themselves. Then we have things like RabbitMQ. Of course, in microservices architecture for the backend, you will need a lot of queuing. So RabbitMQ and Kafka, they are queuing system that helps to queue your request. So it helps to undo queuing because, of course, you're doing a lot of calls to database, so you need some queuing to happen. Of course, databases, you need a lot of database. You need some database, like let's say the NoSQL database. You can use the SQL database and all that. So this is just explaining this concept on the what's it called, on the mountain scope, right? So let's proceed. So now for front end, of course, front end part is quite straightforward, because if you want to build a large system, right, that would probably have, of course, that will be making use of a front end as expected, you have to adopt the component-driven architecture. That is, you will split it into modules. You will split your UI into modules, in the sense that, you need to have feature modules for the front end. So for example, you can have like let's say dashboard module. You can have like, let's say, landing page module. You have to be modular. You have to make it modular. So for example, let's say you have some buttons that will be used across the system. You can create like a button module. Those button module can now have different variations, where you now pass your props to determine if you want it to be blue button, or you want the button to be filled, or you want the button to be outlined and all that. So you have to adopt the component-driven approach. Else you will be spending more time on development. Else your team, because if you don't use that kind of approach, component-driven approach, right, other teams will have issues, using some of these modules. So that's why you need to implement the component-driven approach, in the sense that you need to split things up into feature modules. And that thing for front end is lazy loading. Lazy loading is a very important feature on the front end side of things. That is, for example, you don't have to, if you open a page and all you had to access on the page was just the dashboard, then what's the point of loading up other module that I don't need, when all I access on the app is just the dashboard? So lazy loading is like you saying you only download content from the UI based on what you ask for. In the older times, right, when we don't have lazy loading, what happens is that when you open a website, everything, all the routes, everything gets downloaded onto your system, which of course means that you'll be spending more on data to have a website running. However, with Angular, it's a different ballgame entirely. So that's the point of lazy, because routes are lazy loaded, in the sense that routes are only loaded on the DOM when they are being accessed. That's another thing. And that one concept also state management is very, very important for the front end. For React, we make use of things like Redux. Redux makes use of React makes use of things like Redux. Then Angular makes use of NGRX, RSJS, Signals, NGSS. They are all state management library that can be used to manage state on the front end. Then for PWA, of course, PWA are like PWA in Angular gives it some offline features. So for example, you want to still be able to do some things on your application even though you are offline. With PWA features, you can also achieve all that. Those are one of the benefits. I'm here trying to just let you know some architectural principles that you can adopt on the front end, when you are trying to build highly scalable applications. So let's proceed. Now, what are the best practices you should adopt on the front end? Like I said, I'm using Angular as the front end framework for this session, right? For performance and build, ensure that you make use of AOT compilation. What is AOT? In fact, the recent versions of Angular no longer make use of JIT compilation, right? JIT means just in time compilation, while AOT means ahead of time compilation. So Angular currently offers, latest version of Angular no longer does GIT. They now do ahead of time compilation. This compilation, makes us to have like smaller bundle size, and even makes the Angular application, less prone to error. Then another thing is also optimize. Of course, the compilation also make the optimization, build optimization more sleek, more seamless and all that. Then of course, lazy loading is very important. Like I've said, only load routes that you're accessing, load routes only when you access them. Then of course, the other things like CSS and all those bits. Then of course, state, I said that earlier, and GRX, Redux for global state and all that. Then of course, there's memoization to minimize renders and all those bits from the front end. Then network, we have HTTP2, we have other things like GraphQL, REST, and all that. Those are some of the architectures that I will advise that you use on the front end. Then let's proceed. Then we now have for the back end. I mean, I've spoken about a lot of these things already. What is what's it called? Microservices. Of course, microservices are small, independently deployable services. Yes, microservices is big on independence. That is to say that microservices are small services that can be deployed and owned by teams. So, for example, a team can own payment service. A team a team can own payment service. A team can own dashboard service. A team can own let's say payment service. A team can own dashboard service. A team can own other services within the application, and they are independently owned. That is to say, when one of the services are down, it doesn't affect other services. What happened in monolithic architecture is that when payment services is down, it affects let's say booking services. I mean, booking and payment. Why should that affect each other? Booking should still be working, right? But the appropriate architecture is that when you do booking, as soon as booking is done, it should trigger like a queue. There should be like a queue. There should be like a trigger to book to payment. So when it is queued, right, the payment service picks up the booking and does the payment. However, for monolithic architecture, it's not like that. One, it has to go all the way. So when payment is down, everything is down. But with microservices, everything is. So what about API? What about API gateway? For API gateway, it's a different ball game. It's a different ball game. Authentication, rate limiting, routing, and all that for API gateway. So what I'm saying is that for the API gateway, it can help undo authentication. API gateway can help undo rate limiting, and it can help undo routing. So for example, let's say you have let's say you have 500 let's say you have 500 what's it called, let's say you have 500 services in the part, let's say you have 500 microservices, right? With API gateway, you can channel routing across these services. You can channel authentication. For example, let's say those microservices need you to authenticate just once. With API gateway, you can run that authentication just once without you having to do it across those services. Then for asynchronous messaging, very, very important. Like I said earlier, that things having architectures, having frameworks like RabbitMQ, you can help you undo queuing, such that as soon as a particular what's it called? As soon as a particular services is done, right, it can send items to queue for the next service to pick it up. Then of course, there's something we call idempotency. Idempotency is just a way of, let's say you want to track transactions, track things happening on your system and all that. With idempotency, you can easily do that. It's good for for people that are into logging and all those things. So the next one is just what is the implementation patterns that is advisable to use for .NET Core. I would advise you can, if you don't have, if the what's it called now, if the query doesn't require too many lines of code, you can just implement minimal APIs. Minimal APIs is when you write your code mostly in the program.cs. I mean, if what you're doing is just a simple read, write, and all those things, what using minimal APIs, you can get the job done. Then as well, we have something like else. Yeah, you can build an else endpoint that consistently checks in seconds, that checks in minutes if your API is still running and all those things. There's what we call graceful shutdown. Instead of the system just shutting down all at once, there's a way you can gracefully shut down the system without any issues. Then there's some libraries like Poly for retries. So if something does not go the first time, Poly is used to retry and all those things. Then for data access, of course, EF Core is very good for relational workloads. With EF Core, you can undo migrations easily. You can spin up the tables. You can spin up tables easily. You can spin up databases easily, seamlessly with EF Core. Then you can also use other databases like other database like DynamoDB, NoSQL database like MongoDB, and all those bits. Of course, it also makes read-write faster. Then we have CQRS. Yes, CQRS mostly use the pattern of command and queries. So things that involve some, what's it called? When you are doing GET requests, for example, they are mostly queries. And when you are doing things like put, post, they are mostly commands. That is, you are writing to the database, but queries, you are getting things from database. So SQL is a very good pattern that you can adopt when it comes to data access. Another one is for asynchronous messaging. Of course, RabbitMQ is your guy, Kafka, and all those bits for, those are the things that just make the work easy for everyone, right? So those guys can do publishing, subscribing, and all that. So it helps microservices to speak to each other comfortably, and it just helps the system to to work seamlessly, in the sense that when you come to the system and you log a particular concern, it goes to the queue, the next service picks it up and the process it is. If it doesn't go, poly help to retry and all those bits. That way, the system is working effectively instead of in a monolithic system where when you start the system, right? When you start the process, and if you press at any point, then that is it. Subsequent data, subsequent calls will stop working. But if you are trying to build a large system, when you're trying to build a scalable system, then using this architecture is going to save your day. It can be quite complex at the start, but when you get it right, it's going to save your day. Yeah, let's proceed. Therefore, of course, for data caching and CDN, we have CDN caches, we have Edge for CDN caching, we have App Cache, we have primary storage like NoSQL, we have different database strategies like read replicas, we have sharding. Yes, we have sharding, we have indexing. So in a case where you are trying to access data in your database and it's taking time, of course, sometimes you want to do some queries to the database and it's taking a while. With indexing, you can easily, index your DB and the queries become faster. Then another one is observability. Observability is just around, what's it called? It's just around how you, trace, for example, when issues come up in your system, how do you trace things? So that's around logging. So if you're building a large system, then you must be big on centralized logging. You can adopt frameworks like ELK. ELK is what's it called? ELK is Elasticsearch. Yes, Elasticsearch, Logstash, and Kibana. So Kibana is the UI, graphical UI that you can use to manage logging. So ELK is a go-to guy for logging. You can also use EFK. You can use Splunk. You can use Datadog. There are a lot of them out there that one can use when it comes to logging. And logging is very, very important when it comes to building large system. Logging is so you can know where did the call came from, which of the services, and all those things. Logging is very, very important. So that's why you can use things like ELK, EFK, and Splunk. Then of course for metrics, you can use Grafana. Yeah, when it comes to business metrics, how many requests came in, how many response came out, those kind of things. With Grafana, it makes everything graphically depicted. Then of course we have distributed tracing like OpenTelemetry. Telemetry in the sense that when it comes to some latency and all those things, you make use of that. Then when it comes to observability, yes, that's the go-to guy. Then security and compliance. When it comes to security and compliance, there are a lot of things that can be adopted. So for security and compliance, one of the go-to guys, when it comes to OAuth for security, yes, very, very important. OAuth, OAuth2 for security, for infrastructure, for infrastructure, it's very, very important for us to, use things like Azure Key Vault. So what do I mean? That, for example, when you have some secrets in some people, you make use of their, what's that now? Their app.json, to store their secrets, and it's not safe because it can easily be accessed, right? But with the use of Azure Key Vault, you can save your security keys there. For example, your secret keys. For example, let's say your database, your database configurations and all those very sensitive information, you can put them in your Azure Key Vault. There are a lot of other, other things you can make use of to do this, right? Some use IIS. IIS have some offerings for that. You can also make use of the Azure Key Vault. There are a lot of other things that you can use for that. Of course, and that thing is also rate limiting. Rate limiting is also very crucial in the sense that when for example, when I'm trying to register, when I'm trying to log into a system, multiple times, and I've tried it first time, second time, and it's not working, then prevent the user from logging in again, because it can be a scam. I mean, it can be a fraudulent access. That's why we have rate limiting. So what rate limiting says is that, when you try to access the system a particular number of times, or when you call our API a particular number of times and you cannot gain access, that means, of course, there's something wrong. You now use rate limiting, to stop the guy from accessing the system, maybe after like 5 hours, 6 hours, and all that. But imagine somebody trying to access the system, every 6 hours, and he's not going through. That's going to really frustrate that effort and all that. The rate limiting is also very important. There are a lot of other things like sanitization, sanitize your API calls. For example, some people try to inject some script into your API, so you have to sanitize and all those bits. Of course, data compliance is also very important. So GDPR is not a joke, especially in countries that are very big on what's it called, on data compliance, like the UK, and even in Nigeria. GDPR is, because you can't just be exposing secret information of users all in the internet. So that means you have to always encrypt your data when it's in transit, or encrypt it even when at the point of rest. Also make sure that you encrypt your data. Then, of course, CI/CD is very, very important. It's very, very important. CI/CD is very, very important. So in the sense that, when you build your application, you push to staging and you push, all the way to production. So it's step by step, right? As soon as you finish application on your system, and you push to your main branch. From the main branch, the CI tool picks it up. It does the building. For example, for Angular, it does install all the necessary dependencies and all those things, and builds it. As soon as it builds it, it pushes it on to production. I mean, even from the back, a lot of tools are out there that can do that, for you easily. Of course, a good one is Azure. With the help of Azure, you can do all those kind of things. When it comes to deployment, there's something we call blue-green deployment, right? What that means is that there are some times where you have some older system already on ground, and you now want to deploy newer system. Instead of you to just push all the system, push the newer system, on the users, you just do a blue-green deployment. That is, you do a gradual deployment. You deploy one module, they test it out if it's working, you bring up another module in that process. So there are a lot of techniques that you can use to manage a big, a scalable application. Of course, another one is Terraform. Terraform is infrastructure as code. So this one is like you are pulling up infrastructure with code. It's just like a developer that has his own infrastructure. So with code, you can pull down an EC2. You can pull up an AWS EC2 comfortably. You can pull up. Terraform is one of the things that, of course, when it comes to clusters, when it comes to container orchestration, Kubernetes is another go-to area. So if you want to build a scalable application, CI/CD is one of your go-to, so that you can know how to plan your release. So you can know, because for example, you might want to release only once in a week. Some developers release, some companies release twice a week. So with CI/CD, you can plan your development, your deployment. You can also plan your release strategy. So yes, the lessons from real. So what are the lessons that I want to mention from real system is that there's something we call, of course, real system like Netflix. They make use of microservices. They make use of chaos engineering. That is chaos in the sense that they test for resilience, in the sense that they try to do denial of service attack on their system. They try to pump in a lot of queries, a lot of calls, try to put a lot of inject a lot of scripts into their system just to see how well they can break it down. In fact, there was a research that says that Netflix actually spend money on getting guys to bring down their system. Sometimes they even write code that will bring down their databases and see how fast the system will bring it up. So they're trying their best to bring down the system, and also the system has so much grown such that as you are bringing it down, it's automatically picking itself up. So that's one of the things that Netflix does. And also they make use of global CDNs. CDNs in the sense that when you want to open Netflix, you will not be getting you are not serving Netflix data directly from, let's say, Los Angeles or wherever it is that Netflix is coming from. No, they make use of CDN in the sense that Netflix has other small chunks across African countries. So for example, if Netflix has, let's say, their CDN in, let's say, South Africa, so that means that from here to South Africa, of course, it's a shorter distance. So that's why Netflix applications will load up faster in Nigeria. Somebody in Kenya will also get it loaded up, faster. So if, for example, let's say Netflix has one of their CDNs in Nigeria, automatically, Netflix will come up almost immediately when you load it up. So of course they are caching. Netflix does a lot of caching. So sometimes when you might see that sometimes when new software, when new films comes up, some people might have seen it on their end. You might not have seen it yet. Those things happen. That's why some social media pages, you see that you have dropped. You see that you make a post, and you see that this person has seen the post. This person is yet to see it. Or let's say there was a time I changed my profile picture on Google, and I noticed that it was already showing on my Google Meet, but it wasn't showing on my Teams. So that's just the idea of these things, such that because uploading the profile picture, for example, does not need to happen immediately. So after a while, the system manages like a queuing system to pick it up and reflect it across other applications. The same thing as Facebook, they make use of captioning a lot, graph storage, and all those things. Spotify does event-driven architecture for playbacks, for personalization. They do a lot of all this trendy stuff just to keep their system alive. So what are the common anti-patterns? This is very, very important. What are the common anti-patterns that I want a developer to avoid when it comes to building scalable applications? One of the anti-patterns I want anyone to apply is premature microservices. Exactly. If you're still a company managing, like, let's say 1,000 customers, 10,000 customers, 10,000 even, right? I don't think you should be quick to move to microservice architecture, right? Move to microservice architecture only when there is a need. So don't be quick to move to it, because it can be very, very tricky if not well managed. It can be very, very tricky. It's easier for you to just have a monolith system where you can easily trace how the user logged in, trace what happened in payment and all that, than you going through microservices that you don't, you have to go through your ELK. Imagine, you can't just afford it if you're a small team. So if you're a small team of 10 developers, 20 developers, 1,000 customers, do not go without the microservices. So split only when there's a need. That's why I said that splitting before need is wrong. And that thing is tight coupling. Avoid tight coupling as much as possible. Tight coupling in the sense that let everything be independent. Learn to build in a way that everything is not tightly coupled. Because in the future, when there was a minor change, you'll be taking longer time to make fixes, right? So that's why you need to obey the laws. That's why you need to obey the laws. The laws of object-oriented programming, right? Which are the solid principles. Yes, very, very important. Very, very important. Solid principles. You need to know them. You need to follow that rule so that you avoid repeating yourself. You also avoid tight coupling your code. A part of solid principles says that your code should depend more on abstractions than concrete implementation. That way you can easily change things and all that. There's a lot of them. There's list code substitution. There's open and close principle. There is interface segregation, and there is dependency inversion. A lot of other principles. Now follow them, and you see that you'll be able to build the system, and it's going to be very scalable. Then relying only on vertical scaling. Yes, sometimes when people start building softwares or building startup companies, right, and things start getting slow because of the fact that they have more customers, what comes first to their mind is buying bigger machines. So let's say before you used to use like a big a big storage system, they want to buy a bigger one. Sometimes that's not even the problem. When you're relying too much on vertical scaling, right, it's not good. Most times it's better to go horizontal scaling, replications and all that. So don't make that mistake. Then always do load tests on your APIs. Load test is important. For example, the fact you might be running a company that has 500 customers. In the next 5 months, God helping your company, you might start running for over 50,000 customers. What happens at that point? So that means that when you are building, always ensure that you test your system with, sometimes you want to advise 10 times more data to assure that it's loaded. So for example, if you know that you have 1,000 customers, test your system with 10,000 load. Try to your API with try to log into your try 10,000 users logging into your API at the same time. So that's one of the things you should always look out for. You understand? Run load tests. Check for disaster recovery. What happens if, for example, your database goes down today? So these are the things you need to always check out for. Yes. So, like I said, for this lecture, I have broken it all down. For the front end, I adopted Angular for state management, NGRX, then Angular Universal. Of course, Angular Universal because of when it comes to what's that called now on Google? When it comes to I can't remember right now, but when it comes to you having accessibility for your page to easily have accessibility across Google, Angular Universal is best, and of course SSR, hydration and all that is around Angular Universal. Then of course Service Worker is used for Service Worker is good for in a situation whereby you want to run your services offline. For PWA offerings, Service Worker is your go-to. Then for CDNs, of course, we have Cloud CDN like Cloudflare. Cloudflare went down, I think, 3 days ago, and everything went bad. ChatGPT was not working. A lot of system was not working. I mean, Cloudflare is that guy. So that's to show that a lot of these companies have their system on Cloudflare so that they can easily replicate them across the world. That's why you can easily type ChatGPT and it comes up in a second. So Cloudflare offers these things like that, Azure CDN, CloudFront, and all that. So you can always, exhaust your options. Then when it comes to API gateway, which is like the API gateway, like I said, is like the trafficator, it's like the network, is like the controller that determines what microservices you are going to, that determines what microservices you are going to eat, that you are going to be eating. That determines, maybe you want to do authentication across all the microservices at the time. That is like a central guy that the front end first goes through before going to your microservices. There are a lot of options you can use. We have YARP, YARP, we have Ocelot, we have Managed Gateway, a lot of them that you can use for API gateway. Then when it comes to backend, for this lecture, I exhausted .NET Core. .NET Core is a beautiful, offering that you can use for, it has EF core migration, when it comes to container, when it comes to managing your containers, Kubernetes is also a very good one for container orchestration and all those bits. So yeah, for messaging, I also listed that we have Kafka, RabbitMQ. When it comes to queuing, when it comes to there's also Azure Service Bus. When it comes to passing information from A to B, those are the. But I will quickly suggest RabbitMQ because it's an open source that you can easily use for whatever it is you want to do. Then for DBs, there's PostgreSQL, there's SQL Server, there's MongoDB, there's Cosmos DB, there's a lot of them. There are a lot of them. Well, mostly for me, I use a lot of SQL because I work a lot in the financial side of things. So we are very big on SQL Server and all those things. Therefore, observability is when you want to trace things to be sure that everything is where did the call came in from? Was it from a mobile app? Was it from a web app? What did all those anything that involves checking, logging, checking for where something was going on? Then you have OpenTelemetry, we have Prometheus, we have Grafana, we also have ELK. Yes, I use ELK a lot. ELK is one of the go-to guys when it comes to, of course, a lot of other ones like Datadog, a lot of them like Sentry. They are free, you can check them out and all that. Then when it comes to CI/CD, of course, we have GitHub. GitHub is like the go-to for every other person. It's free. You can just go there to GitHub Actions. GitHub Actions can be used with the front end. For example, when you push your code, GitHub picks it up and builds it and do the rest for you. Then of course we have Azure DevOps. Azure has a whole lot of offerings when it comes to CI/CD and all those things. There's GitLab CI. There's even there's even one from Google. I remember that. Google has its own offering as well when it comes to CI/CD. So yeah, thank you very much. That is my time, and I've taken time today to go through the entire length and breadth of building scalable architecture, in the sense that I've explained how you can have like your front end in modules simplified. Some people even go ahead to implement something like micro front end on the UI. Micro front end is just like microservices in the sense that you have your front end services in chunks managed by different teams. It can be very complicated. That's why sometimes I don't even advise going that route for the front end. However, there's also there's something we call micro front end. There's something that we call there are a lot of other offerings when it comes to the front end. Because micro front end is very, very important to also know. It's a way for you to also split your front end into smaller chunks. Then another one, and that concept is also the API gateway. Very, very important concept in the sense that the API gateway is like the middleman between your front end and your microservices. That's where you do the route do your routing. That's where it's any authentication you want to do across the services. That's the guy. Anything that involves authentication, anything of such. Your API gateway helps to handle that out of the box. And then of course you have the microservices where you have all the services where you have services in different chunks, independent of each other, and they can communicate using gRPC. Is they can easily communicate to each other, and and you can also use things like Kafka, RabbitMQ for queuing and all those bits. So that's just the concept around building scalable architecture. So if you are thinking building scalable architecture, you have to think around these things: microservices, micro front end, API gateway, telemetry, Kafka, RabbitMQ, a lot of CI/CD, very, very important. So yeah, that's what I've come to deliver today. Thank you very much. And my name is Ayodeji Saliu. I'm a senior software engineer at Andela UK. Thank you. Yeah, I'm done.